Hey everybody, welcome. In this video, we're going to take a look at the Chapter 8, Day 4 notes, where we're going to look at solving radical equations. So we'll start out by talking about the steps to solve radical equations, then we will go through some examples. All right, so there's probably different ways to think about this, but the way I like to think about step 1 is we are always going to start by isolating the radical. So we want to isolate the radical, which is that root symbol. Now, usually we talk about square roots, but there are cube roots, fourth roots, fifth roots. Okay, any one of those uses this radical symbol. So we can go ahead and put an n here to represent different indexes. So if you change n, you're going to change the root that you're taking. Now, one thing about this is sometimes the radical is going to be on both sides. So you might want to make a little note that you can have a radical on both sides. And that's okay. All right, the next step sometimes can be confusing when people first hear it. But for step 2 is we're going to take the corresponding power of both sides. Now, what I mean by that is if it is a square root, you are going to square. All right, so you're going to square a square root. You're going to cube a cube root, etc. So if it's a fourth root, you're going to take it to the fourth power. That's what I mean by taking a corresponding power, because the goal is we're trying to take the power that's going to be the inverse function of the root that we have. Step 3, we're going to solve for the variable. Now with these problems, there is also kind of a key part here to pay attention to, and it says up here in the directions, solve the following equations. Check for extraneous solutions. So we always want to check at the end of the problem to see if we have any extraneous solutions. Now, typically what that means is a square root cannot equal a negative number. We cannot take the square root of a negative. So if I have the square root of a negative, that's a no. So those would be situations where we potentially have extraneous solutions. So, just kind of keep those in mind when you're thinking of checking your answers. All right, so we got a couple examples below. What I would recommend you do is try each of these on your own, pause the video, and then, start it again to see how you did. Okay, so for number 1, if we focus on this, we're going to start by isolating the radical, which in this case, we have our square root isolated. All right, from there, we're going to take the corresponding power of both sides. Well, the corresponding power of a square root is to square. So we're going to square the left side and the right side. When we do that, we're going to end up with 3x plus 2 on the left side, and the right side is 3 squared, so 9. From here, it just becomes like any other equation that we've solved. We're going to go ahead and subtract 2 from both sides. So if we subtract 2, we get 7. Then we're going to divide by 3. So x is equal to 7/3. Now, if you were going to check your answer, which you can do this mentally, you don't have to write this out every time. But if you were to check the answer, we would be saying, okay, the square root of 3 times something plus 2 equals 3. Well, the something would be our 7/3. So this would now be 3 times 7/3, which is 7 plus 2 equals 3. This would be the square root of 9 equals 3. Is that true? Yes. So therefore, 7/3 is the answer. Like I said, the check doesn't always have to be done on your paper, but you should at least go through that process mentally to make sure the answer fits. All right, number 2. So again, if you haven't tried it, I would pause it and then try it. So now we have an example where we have square roots on both sides. All right, but they are the only thing on their sides. So this is considered having the square root isolated or the radical isolated. So we can go ahead and now take the corresponding power to both sides, which is 2. On the left-hand side, that's going to leave us with x. Sorry, let me change the color here. All right, that's going to leave us with x plus 6. And on the right side, it's going to leave us with 2x minus 3. All right, now we're just solving an equation that has variables on both sides. I would go ahead and subtract x from both sides, which would give me x minus 3. Then I'm going to go ahead and add 3 to both sides. So 9 equals x. And again, I just want to double check to make sure that I'm not going to get a negative under the radical. So 9 plus 6, that's positive 15. 2 times 9 is 18. 18 minus 3 is also positive 15. So we're good. X equals 9 is the answer. All right. So that's just kind of showing you with square roots. But the deal is we're not always going to work with square roots when we're dealing with radicals. So let's take a look at number 3. Again, I would pause the video and try it on your own. So step 1 is to isolate the radical. This time, the radical is the only thing by itself. Step 2 is to take the corresponding power. This time we have a cube root. So the corresponding power is going to be cubing, or the third power. So we're going to take the third power on both sides. On the left side, we simply are left with 12x. On the right side, we get 6 cubed. Okay, now 6 cubed does not mean 6 times 3. It means 6 times 6 times 6. So 6 cubed is 216. From there, we're going to go ahead and divide both sides by 12. So 216 divided by 12. We should go ahead and reduce if we can. So let's just see if 12 goes evenly into 216. It does. It goes in 18 times. X equals 18 is going to be the answer. Now, it does say check for extraneous solutions. One thing to kind of understand is with cube roots, we're able to take cube roots of negative numbers and we are able to get negative numbers when we cube root. So there are not going to be extraneous solutions in this situation. All right, number 4. Now in this case, we've got a little bit of work to do, all right? When we look at the problem, we've got a radical, in this case a square root. It is not isolated. So the very first thing we're going to have to do is get this by itself. I'll try a different color. All right, and you could, in theory, do this a couple different ways, but the way that makes the most sense to me is going to be to subtract 14 on both sides. So we got 2 times the square root of the quantity 6x minus 7. We're going to subtract 14 from 4 to get negative 10. I still don't have the radical isolated. So now we're going to go ahead and divide both sides by 2. So we get the square root of 6x minus 7 equals negative 5. Now, a lot of people will continue to keep going here. And my guess is if you paused the video and tried this, you did that. And if you did, all right, you could continue to work. You'd get 6 squared, you'd square this. That would leave you with 6x minus 7 equals 25. You could add 7, 6x equals 32. You could divide by 6, 32 over 6. That reduces by 2, and you get, what, 16/3. The problem is you would be wrong. If you continued and you did this, it would actually be wrong. Because if you look at what we had right here, we say that the square root of 6x minus 7 equals negative 5. Well, up above, I made the note that square roots cannot equal negative numbers. So any square root cannot be a negative number, and that's what we have happening here. So you want to make sure you recognize that, and when this happens, our answer becomes no solution. Because no matter what, when we take the square root of a negative number, it will be positive. So you get to here, you isolate the root, it's a square root, it can't be negative. Now to extend that, it's any even root. So if I have a square root, a fourth root, a sixth root, those cannot be negative. All right, let's take a look at the next one. All right, number 5. Now we've got the quantity x minus 2 equals the square root of x plus 10. We have our radical isolated, so that's a good start. Now we want to take the corresponding power. So the corresponding power of square rooting is squaring. You need to be careful on the left side to make sure you're squaring the entire quantity. Now, this really means x minus 2 times x minus 2, which will give us x squared minus 4x plus 4. Okay, and if you're not sure how to get there, I could show you a little side work over here. We got x minus 2 times x minus 2. We distribute, we got x squared minus 2x plus 4. And then those combine to give you x squared minus 4x plus 4. All right, now on the right side, the square simply cancels out the square root, so we have x plus 10. Now we have a situation where variables are on both sides, but we also have x squared and x. We need to set it equal to 0. So for me, I like to always keep my x squared positive. So I'm going to move everything to the left. So I got x squared. If I subtract 1x from negative 4x, that's negative 5x. If I subtract 10 from 4, that's negative 6 equals 0. Now we can go ahead and factor the trinomial. All right, we got x squared, which is x and x. The negative here means plus minus. Now, with 6 and 5, you got to be careful because 3 times 2 is 6, 3 plus 2 is 5. 6 times 1 is 6, 6 minus 1 is 5. So what's going to play a big role here is the different signs, which means you're going to be subtracting to get 5, not adding. So the factors of negative 6 that are going to multiply by x and x to give me negative 5x will be positive 1, negative 6. Now, that means that negative 1, positive 6 are the possible answers. You might think we're done, but we have to check our extraneous solutions. So in this particular example, if I were to plug negative 1 back into the original equation, I would have negative 1 minus 2, which gives me negative 3. Square roots cannot equal negative numbers, therefore we reject the negative 1. If we do the same thing with plugging in 6, 6 minus 2 is 4. If I plug in 6 to the right side, 6 plus 10 is 16. The square root of 16 is 4. So 6 becomes the only solution to this equation. All right, next. Okay, number 6 is going to be very similar to number 5, but this time the radical is not isolated. So we're going to have to go ahead and subtract 5 to both sides. So we get the square root of x minus 3 equals x minus 5. Now we can go ahead and take the corresponding power of both sides, which is squaring. Don't forget to square the entire binomial. We're going to get x minus 3 equals. So kind of similar to what we did over here with this work, you're going to do the same thing here. So we're going to get x times x, which is x squared. X times negative 5 is negative 5x, but there's 2 of those, so that's negative 10x. And then negative 5 times negative 5 is positive 25. Well, we get to that same situation, variables on both sides, but we have x squared and x, so we're going to set it equal to 0. This time, to keep the x squared positive, I'm going to move everything to the right. So I'm going to put my 0 over here. The x squared is going to stay. We're going to subtract x from negative 10 to give us negative 11x. And we're going to add 3 to 25 to get positive 28. All right, when we go to factor this, we're going to have 0 equals our 2 binomials. X squared is x and x. This time we have a positive 28, so the signs are the same, both minus. Factors of 28 that are going to combine to the 11x, I know are 7 and 4. So we get positive 7 and positive 4 as our possible answers. Now, same idea has to apply. When you are substituting back in to check, does the answer make sense? I would always do it to the step where you isolated the radical. because it's the radical that cannot equal a negative and a negative that can't be in the radical. So if I plug in 7, 7 minus 3 is 4. That's fine. 7 minus 5 is 2. We're good. If I plug in 4, 4 minus 3 is 1. Square root of 1, I can do that. 4 minus 5, that's negative 1. Okay? My square root cannot equal this negative number, which would be negative 1, so we're going to reject. Again, leaving us with only one answer, x equals 7. Now, last thing we have on the notes, it says, check example 5 by graphing it in your graphing calculator. So we're going to graph two functions, f of x equals x minus 2, and g of x, which is the square root of x plus 10. And we're going to look and see what we notice. So I'm going to pull up a graphing calculator here. And if you're at home, you could use Desmos to do this if you don't have a graphing calculator. This is just going to take a second to load. Clear what we got. All right. So the first function we wanted to graph was x minus 2. And the second function we wanted to graph, let me double check here, was the square root. So I'm going to go second square root of x plus 10. All right. When we hit graph, let me kind of give a better window here. So I'm going to go zoom, just give me a standard window. All right, so this, the blue graph is the line x minus 2. The red graph is the graph of the square root of x plus 10. Now, you'll notice that they only intersect at one single point. The point of intersection is basically where they're equal, which is what we were solving, is when are these two functions equal, okay? So if I were to go and calculate where they intersect, I can do the intersection, which is 5. I just want to choose this function, then this function, hit it again, and we're going to see that they only intersect when x equals 6. If we come back over here to our answers on number 5, our answer was x equals 6. We did not get, we had to reject the answer of negative 1. And again, if you look graphically at negative 1, these two functions, they are not equal to each other. So this is just kind of another visual representation of why sometimes we have to reject certain solutions. All right, guys, I hope you found the video helpful. If you need to, go ahead and watch the video again, or check in with your teacher for some extra help. Have a good day.